Matthew, am I audible to you?
Yes, sir.
Okay, fine. I am dictating a question. You should try to do it. Actually, today we will discuss the mixed question of wave optics. All right, Matthew.
Okay.
Now write down the question, Matthew. Two slits are made 1 millimeter apart. Two slits are made 1 millimeter apart. Am I audible, Matthew?
Yes, I'm writing it.
Okay, fine.
PPT.
Two slits are made 1 millimeter apart. The screen is placed 1 meter away.
Okay, sir. Okay.
What is the fringe separation between blue-green light of wavelength 500 nanometer is used? 3 minutes. Try to do it. And if you don't get it, please let me know.
So can you say the wavelength again?
What is the fringe wavelength 500 nanometer is used?
Okay, sir.
3 minutes to do this question. And if you don't get it, please don't sit quiet. All right, please let me know. We will discuss.
Sure, sir. So is it 0.5?
Just a minute. 0.5. Fringe width.
Yeah.
Just a
0.5.
minute, Matthew. Just a minute. Which formula did you use, by the way?
Lambda d by d.
Okay. The answer is 0.5 mm.
Yes, sir.
Great. Next. Just a minute. In YDSC experiment, the two slits
Yes, sir.
in YDSC experiment, the two slits 0.15 mm
Yes. Yeah.
apart are illuminated by monochromatic light
Okay.
Monochromatic light of wavelength 450 nanometer full stop. The screen is 1 meter away from the slits. The screen is 1 meter away from the slits. Calculate the distance. Calculate the distance
Yes.
calculate the distance. Sorry, just a minute. Could you repeat the question? In YDSC, select the two slits 0.5 are united.
Yes.
Okay.
0.15
Wavelength
nanometer
415 is
450
illuminated by
nanometer.
450 nanometer. The screen is 1 meter away
1
from the
meter away.
calculate the distance of the second.
Okay. Yes, sir.
Second, bright fringe and dark fringe from the central maxima. Second part.
No.
How will the fringe pattern change? How will the fringe pattern change if the screen is moved away from the slits? Dan Matthew. Done, Matthew? Or still are you doing?
One-
Are you getting?
second part of the question. Yeah, I got the
The
first.
question is very easy, isn't it? Just substitute the value in the formula, you'll get the answer.
So is it 6 and 4.5?
Just a minute. Answer is
6 nanometer for the first one and 4.5
6.
nanometer for the
Just
second.
a minute. The first answer is 6
6,
mm.
yeah.
6
Yeah,
mm.
yeah. Yeah, millimeter, sorry, yeah.
And second is 4.5 mm.
Exactly.
Great. Correct. Next, right. You're pretty good in wave optics.
Thank you, sir.
Next, write down the next question. A beam of light consisting two wavelengths. One is lambda 1 equals to 650. How's your preparation, Matthew, by the way, for boards?
Sir, it's going on well. I'm starting off with the part 2 chapter.
How many chapters you have completed so far?
I'm done with magnetic effect, the first 2 chapters, electrostatic potential and capacitance, and the other one.
What about the second book? Second book you also done?
Second book I'm finishing, sir. I'm done with dual nature, ray optics, wave optics. I'm also revising. That's why.
You have done each and every question of NCRT.
NCRT questions I've revised. I've also done some
Okay.
SLR.
Now it seems means you are able to do each and every question, means this is a third question. You did both the questions. It seems
wave optics is a bit more easier.
Wave optics?
It's a bit more easier for me.
Okay, easier for you. And do you know one thing, means most of the students usually find difficulty in wave optics.
Oh, okay. Because I feel like the formulas and
literally I'm telling you the truth. Means most of the students usually they find difficulty in wave optics. And how's your electrostatics, by the way?
So first chapter I'm pretty good at that. Second chapter I still need to revise a bit more. So.
Capacitance. You are okay with capacitance also? Not
clearly, but yeah, pretty much, yeah. It's because that I can sometimes confuse for the series and parallel thing. So,
yeah. Okay. But some of the derivations not in CBSE, for example, the energy stored in a capacitor.
Yeah, sir.
Don't study too much. Okay, before studying any of the topics, just go through the syllabus.
Sure, sir.
Now, the question: a beam of light consisting two wavelengths, 650 nanometer and 520 nanometer.
Yes, sir.
Is used to obtain interference fringes in YDSC. Full stop. What is the least distance from the central maximum? What is the least distance from the central maximum where the bright fringes due to both wavelengths coincide?
So can I repeat the A1 again? First one.
Just a minute. What is the least? Have you written?
Yeah, the last part I've written is interference fringes in YDSC.
What is the least distance from the central maximum where the where the bright fringes due to the both wavelengths coincide? The distance between the slits is 2 mm. That is small d. Yeah. And the distance between the plane of the slits and the screen is 120 centimeters. Means capital D. 2.
millimeter, right, sir?
What?
Capital D is 120 millimeter, right?
120 centimeter.
And small d is 2 mm.
Small 2 mm. 2 millimeter.
So is it 1560000?
Just a minute. One over 6.
15600.
156. 1.56 mm.
Yes, sir.
You create the equations and nothing.
I did it in terms of meters, sir.
Write down the question. This is the figure. Then the intensity at central maxima. The intensity at central maxima The intensity at central maxima in YDSC experiment is I naught. First up, if distance OP, P, if distance OP equals 1/3 of the fringe width of the pattern, this OP distance equals 1/3 of the fringe width of the pattern, show that the intensity at P will be I naught over 4. Do Matthew written?
So can you repeat from distance OP?
Distance OP equals to 1/3 of the fringe width of the pattern. The intensity at P would be I naught by 4. I just come in a minute. Matthew done?
Not yet, sir.
Do you know how to do it?
Kinda, yeah.
Look what we have to do it. This formula we have to use it. I equals
Lambda d by d.
no. Yeah, but this formula to calculate the intensity.
Oh, okay.
I equals to I naught cos square 5. Look, we have to calculate the phase difference. All right.
Yes.
Look, how would you calculate the path difference? The relation is phase difference equals to 2 pi p over lambda. And what is beta? Beta equals to
Lambda d by d.
lambda d by d. Further, what is y? Y is 1/3 of beta. So y equals to 1/3 lambda d over d. Now what is y? Y is
1/3 beta.
basically it is the distance from the central bright. So what is the formula, by the way? Y equals to, I think,
Lambda d by d.
d over d. I think this is the formula. So P d over d equals to lambda d over d. D will cancel out PP. So part difference equals to lambda over 3. Now substitute the value of P in this formula. Then you'll get the value of phase difference. Substitute the value of phase difference in this intensity formula. You'll get the answer. Now let me know the answer. Try.
Yes, sir. You'll get I0 cos square 2 pi by 3.
2 pi by 3. Just solve it. 2 pi by 3 over pi also. Pi by 3.
So you should calculate pi as well.
Pi. Look, 2 pi by 3. You'll get pi. 2 pi by 3 is a substitute in this formula. I equals to I naught cos square pi by 2.
Yes, sir. You get I0 by.
Finally got the answer.
Yeah.
Next. The question is based on this formula a little bit. You have to use this formula. Okay. Now start writing. In YDS experiment,
Yes, sir.
the intensity of light at a point on the screen in YDSC experiment using monochromatic light of wavelength lambda, the intensity at a point on the screen where the part difference is lambda, is K units. Find out the intensity of the light at a point. Find out the intensity of the light at a point where the part difference is lambda over 3.
Where part difference is?
Lambda over 3. Now try. It is an NCERT question also.
So is it K by 4?
Yes? Yes,
K by
Matthew?
4, sir. K by 4.
K by 4. I think this is correct answer, but let me check.
Yeah, because you get lambda equal, sorry, yeah, pi 0 equal pi delta phi equal to 2 pi by 3.
Just a minute. Yeah, K by 4. Good. Now, next question. Single slit, I think. A parallel beam of light of wavelength 500 nanometer resulting diffraction pattern is observed on a screen. The parallel beam of light wavelength 500 nanometer falls on a slit and reflection is on a screen meter away. It is observed that the first minimum is distance. It is observed that the first minimum is distance 2.5 mm from the center. Find the width of the slit. I think it is YDSC question.
ये है कि जो आपसे सच्चा प्यार करता है, जो सच में आप में इंटरेस्टेड है, वो अनगिनत कारण ढूंढेगा आपसे बात करने के लिए, आपसे
Matthew, are you Matthew?
What's the question?
I'm the question. Just a minute. The question is, a parallel beam of light of wavelength 500 nanometer falls on a narrow slit. The resulting diffraction pattern is observed on a screen 1 meter away. It is observed that the first minimum is at a distance 2.5 mm away from the center. Find the width of the slit. Small d we have to calculate. Have you written?
Sir, your mic is muted.
What is the answer?
Sir, what should I write?
I told you the questions two times. You didn't write.
What, sir?
Didn't you write the question?
Sir, can you repeat? I can't hear you.
A parallel beam of light wavelength 500 nanometer